Yeah, hi everyone. So in this session, I will present this feature store solution that we have in the feature store. I think the focus here would be will be on the how the feature store is driving the efficiency and quality for some feature engineering process in some teams at Delivery Hero. And I will talk about our context, workflow, and some parts of the architecture. And before jumping into the presentation itself, I just want to talk briefly about the Delivery Hero, if you don't know, and where my team fits in the organization. Delivery Hero is a food delivery company founded in Berlin, that became a global company. Delivery Hero is a holding of different brands, and we are present in over 70 countries across the world. You might have used some of these apps of some of these brands here, like Foodora in Europe or Foodpanda in Southeast Asia, Glovo in Spain, Pedidos Ya in South America, and all of these brands are part of the H. And we have an internal platform called Pandora. Pandora is the internal name that powers some of these brands of Delivery Hero. And I'm from the ML platform team within Pandora. And we have some cross-functional squads in Pandora. These squads work on different aspects of the product. And I think our mission as a team is to standardize some the ML lifecycle. We try to provide some platform components to cover the different parts of this lifecycle. That's our mission. We have some other different platforms within Delivery Hero that use different solutions, but just to show to you how this ML platform team fits in the organization. Back some 1 or 2 years ago, we were evaluating our context in our tribe, and we have this kind of context. The data science and ML engineers, they create their model implementations in different GitHub repos, and we provide some model interface, and they have to implement the training and the inference parts, and they use it to create the features for ML models inside these model repos. But this became inefficient for the company as the number of people, teams, and projects scale up. And we saw that features are not easily reused across different projects. Similar features were created over and over again. And there are some lack of standardization for the process, like the feature generation and feature quality process. And we decided to move forward with the feature store idea, and we decided to implement this feature store as a way of mitigating part of those issues. And the feature store acts as a central component that allows the people to create, serve, monitor features. This is not only the store part, let's say, but I will show some other parts of the architecture. And we've seen that this has been increasing the feature reusability, and most of the feature generation and monitoring processes are standardized. And as a consequence, we've seen increased consistency and quality, and reduced effort to create new models. And in our case, we have some different kinds of features. For example, we have some features which are calculated by in real time, let's say, because they depend on the input of user. For example, the location is one input provided by user to use the Deliver app, and we have some features calculated based on their location. We also have some features calculated every minutes, but the most of features are calculated in batch. I will focus more on this batch part in this presentation. because I think we have more platform components provided for this use case. Let's talk about workflow. In our case, we decided to create one feature repo. All the features are in the same repo, and we maintain this feature repo as a platform team, but the users can contribute to this repo to create features, to make configurations, and the same repo is shared with different teams. They have permissions to create branches, open pull requests, and so on. And within this repo, they just need to clone this repo in their local machines, and they can create and test features using their development tools. Let's say they have VS Code or PyCharm, these development environments. And everything they need for development purpose is out there. They just need to create the feature transformation codes. They have a CLI to run these features. They can create some configuration to monitor the features. They have a CLI to run the monitoring modules, and they have access to some reports and so on. And when the development is finished, they open pull requests, request reviews from their peers, and this is also part of the process to guarantee the code quality and consistency. I think this is very important. And the CI pipelines are triggered as soon as the PR is merged into main branch, and those pipelines update some remote configuration files, some Airflow DAGs. They don't need to interact with the orchestrator, with the Airflow to run the features. We have some pipelines that make this in automated way. And just to show some high-level architecture, we have some components here. The feature transformations components allow us the users to create features using SQL or Python. They can choose according to the use case. A feature monitoring component, we have two kinds of monitoring. One is using weight expectations to set to run some assertions on the data, and also a component to detect drift detection. And these are pipelines managed by the Airflow, and the feature transformations, the pipelines ingested data to offline and online store. And as offline store, we are using BigQuery to run the SQL transformations and to store the data, the historical data. And we also use the REDS as our online store to provide the low latency database for model server APIs. And FIST, we are using to provide a registry layer, some materialization jobs, and also to provide the SDK to get historical features and online features. This is the high-level architecture. Let me talk about the components. Feature transformations in Python. This is mostly used when they need to write some features that need some more complex transformations that cannot be managed in SQL, or when they need to use some Python package to apply some transformation function that is not available in SQL. They can use this. We rely on Kubernetes to run the transformations in Python, and this is orchestrated by the Airflow. And we also have this module to create the feature transformations in SQL. Data scientists can write their features using SQL, and this is definitely the most used one. I think the combination of dbt and BigQuery gives us many benefits. Both tools are extensively used at Delivery Hero, but I think they are mostly used on the data engineering side. But we decided to use especially DBT because it provides some benefits for us. Let's say BigQuery is a tool that makes it easier to manage the pipelines, your SQL scripts. For example, if you have a complex transformation pipeline, you can decompose your pipeline in different steps, and DBT provides some functionalities for that. It has a good usability. It's flexible for different data sources, and it has a seamless integration with BigQuery. And BigQuery is good also for many reasons, because it is serverless and provides a high processing power to bring scalability to our workloads. And regarding the cost in live project, we have used the flat rate compute pricing to manage the cost, and in staging for development, we have used some recent feature released by BigQuery, which is the auto-scale, to auto-scale the slots, the processing slots in BigQuery. Just to provide one example of feature transformations, in the feature repo, they have this kind of folder structure. For example, there is a folder called features, and this folder contains a subfolder DBT, and there are some features grouped by entities. Some examples of entities are vendors, products, and customers. But for this example, I just create one project called Sandbox. I cannot disclose some details on the feature transformations, but just to give you an idea of this, I just create one vendor popularity features.sql file, and the content of this file is shown at the right. In the file, you can see at the top of the file, we have some configurations. This is a mix of DBT configuration and BigQuery configuration. And with this configuration, we can define some configuration for the tables, for example, the partitioning and the clustering. And we can also make some configurations on DBT, how DBT will materialize the data, what will be the incremental strategy for DBT, and other aspects of DBT can be defined here. And the data scientist can write a SQL file. And this is an example. If you look at the line 15, there is a brackets. This is part of the DBT syntax. With DBT, you can call some functions or macros from DBT, and this helps to create the scripts. And just to give another example, at line 25, there is a function called ref, and in DBT, you can use this ref function to use the results of a table that will be produced by another script in your project. For example, order with matrix is another script called orderswithmatrix.sql. And when you do that, when you create your SQL in this way, DBT will automatically generate the dependency graph for you. You don't need to do nothing. Yeah. And DBT also offers CLI. With the CLI, you can run the SQL scripts. You can run all the scripts. You can run a subset of them. You can also run some tests. You can create tests for your SQL. And you can manage the dependency graph, as I mentioned. For example, this is a screenshot of a documentation page from DBT. And in this documentation page, you can see the lineage graph generated by the DBT. The vendor popularity features, the right of this lineage is the actual feature table, let's say. And this script uses order with matrix as a dependence. And Other with metrics use another ones as dependency, and dbt provides this this kind of management for us. I think one benefit of another benefit of dbt is with this pipeline decomposition, we can also reuse some intermediate transformations. For example, the orders past 60 days is a SQL script that can also be reused, because this will produce a table that can be reused. This is another benefit of dbt. You cannot reuse only the features, you can also reuse other parts of the transformations. And other component of our feature store is the feature monitoring part. We have two components, as I said. The first one is quality checks. This component is built on top of Great Expectations. Great Expectations is also extensively used at Delivery Hero. But for our use case, we decided to create one wrapper on top of Great Expectations to make it easier for data scientists and ML engineers to create this. For example, the folder structure is quite similar than the transformations one. They just need to write one module. For example, vendor popularity features is a monitoring module in this context. They need to write a function to fetch quality checks, and they need to write these expectations for the data. And this is a syntax from the Great Expectations. And they also have a CLI to run these monitoring modules and have access to the reports. And these reports on the right side is generated by Great Expectations. And they can see the number of evaluated expectations, how many expectations have failed, and they have details about the failure. They can use this report to debug the issues and to fix the problem. This is the first one. The second one is for drift detection. The folder structure, the idea is the same. They have this folder structure. They can reuse the same Python module to define the monitoring module, the vendor popularity features. But for drift detection, they need to write this function, fetch drift config, and they just need to return this drift config. And this drift config contains some information about the columns that will be analyzed, the metrics that will be used to calculate the drift, the distributions, and the threshold for each column. And this component is built on top of Evidently AI. When the pipeline runs, it calls the Evidently AI to runs this drift detection. And they also have a CLI to run this monitoring module and have access to the reports. They can run this in their local environment and have access to these reports. This is an example of a report generated by this drift configuration. It has 6 tests, and when one test fails, you can see that it was failed, and you can see some chart. And this is also automated. I will show later how this is automated, but they have access to these reports on the live environment. And we, as per our experience, we have detected a lot of issues with these two components. For example, unexpected duplication of keys in some data source tables because of many reasons, because someone changed the application that produced the data, for example. This is one reason. And there are other detected issues. For example, some events that happen in some countries that was triggered by some event that we don't have much control on. This has happened sometimes. Or the classical error, let's say, some data production pipeline has changed, has changed the ETL scripts, or has deprecated some table or field, and so on, and that produce incorrect data. And all of these issues can be detected by these monitoring components, and this brings some quality and reliability for the feature data which is produced in the feature store. In terms of feature registry, we are using the feast, as I mentioned, and the feast you can define the data source that you want to use, and you can define the feature view and the feature service. For that example, I just define here one feature view with the schema, with a data source from BigQuery, and with the schema, you have to define the name and types. And for feature service, I define this feature service with only one feature view, but you can combine some feature views to create one feature service. And Feast provides this user interface with the entities, with the feature views, feature services created in your registry. You have access to this feature view. They can version the features, and using Feast, they can also create a feature views using different data sources. For example, they can create using stream data sources or some files as a data source, and so on. But in the feature store for batch features, we use the BigQuery, as I mentioned. And the feature serving part, we have to create some setup to deploy these different RADS instance in different geographical regions, because we have some constraints about the latency, some requirements, type requirements about the latency for model server APIs. And we have this multi-regional setup. Just put 2 regions here to give an example, Asia East 1 and Europe West 3. But the idea here is we have the RADs in different regions, and we have the model server APIs deployed in different regions as well. And we can have the model server APIs in the same region than RADs. And this to reduce the total latency. With this setup, and with some optimizations on Fish SDK, I think it's important, something important to say. We have to make some customizations on the Fish to materialize data in different regions, because it's not kind of supported on Feast. And we have this setup, and we have good numbers of latency. We are able to, for some use case, we are able to fetch data with less than 5 milliseconds for P99, and this is a good number for our use case. And for pipelines, we use the Airflow to orchestrate the feature pipelines. For example, this would be like the DAG for this example proposed by me in this presentation. We can reproduce the same dependency graph that is generated by DBT. We use the DBT manifest file to generate this dependency graph on the Airflow, and we can reproduce the same. If some task fails, we just need to resume from that task and to save resources, computational resource. And they can also backfill tables. There is a configuration that can be used to backfill tables, and these DAGs are generated dynamically, programmatically. They don't need to interact with a flow at all. And these DAGs run on live environment, and if some issue happens, for example, feature transformation is failed, or the data quality issue is found, is raised, they receive Slack notifications. They can have access. They can click on the issue and have access to the reports. For these, we have the reports stored in our metadata tracking server, both data quality and brief reports, and they can be verified by users. And just to finish my presentation, some takeaways from our side. I think having this central component actually promotes the reusability of features. I think at the beginning, this might be hard to get adoption from all data scientists because we have to onboard them into a new tool. But little by little, they are sort of convincing when they see that they can reuse some features from the repo, when they contribute to their features to this repo, and this will be reused in different models. And this is very important for the long-term objectives, long-term goals of the company, because the data scientists can leverage existing features, and this reduce the creation of redundant features, and also to reduce the engineering efforts on squads, since a big part of the job is provided as a service. And I just put some articles here in the presentation. When you have access to the presentation, you can go to our tech blog to have more details. We have 2 blog posts on the feature store, and one for feature store, one for feature monitoring, and another about the personalization strategy at Delivery Hero. Yeah, thank you so much.
Brilliant. Thank you, Breno. Great to see the great work you're doing and bring machine learning to production at Delivery Hero.